Hey-o, how's everybody doing? Pre-calc, solving logarithmic equations. Yeah, the face I'm making in this lead slide here is the face a lot of kids make when they're solving logarithmic equations, but hopefully by the end of it, you're going to love it. It's easy. All right, so how to solve a logarithmic equation. In these logarithmic equations, the variable we wish to solve for is inside of the log. And our goal is to get it out so we can solve for it. Now, the reason why I feel the need to say that is sometimes you may see log base 2 of 18. There's no variable there. There's nothing to solve for. You can use your calculator. This is a number. It is a number. Figure it out. Use your calculator. So there's nothing to solve for it. I'm talking about when there is a variable like log base 2 of x plus 4. Now all of a sudden I got a variable inside the log. I got to solve for it. So there's a few different ways that we could do this. Oh, typo alert. But we will always need a few big ideas. First, we need to know the properties of logarithms. So if you haven't watched that video yet, highly encourage you to do so. We also need to know the basic definition of what a log is. Once again, that's in the property video, so make sure you understand that. And finally, we need to know one other very simple fact. You cannot have negatives inside of a log. In fact, we'd actually amend that a little bit. You cannot have any value 0 or less than 0. So not even just negatives. You can't have any value less than or equal to 0 inside of a log. So you got to be very careful. If at the end of the problem you think you know what x is, double check. If you plug x in and it somehow makes a 0 or a number less than 0 inside of the log, be careful because that's not an answer. All right. Let's just jump right to it and check out a couple of examples here. All right, so got to solve this problem. First couple things I want to make sure you understand is that what's the base on this log? Because some kids will say, there's no base, I can't do it. Yeah, it's base 10. Remember, anytime we just write log with no base, it's implied it's base 10. So what can I do here? Well, one thing I could do right away is I could use the definition of a log, or I could actually start by using a property of a log. So let's do a property first. I'm going to show you both ways. So I could drop down the 2. That's the power property. So I have 2 log x equals 2. Then I could divide both sides by that 2 because now that 2 is just a coefficient. I could divide it over. And I have log of x equals 1. And then I got to ask myself the question, right? This is where I'm using the actual definition. This statement right here is equivalent to me saying 10 raised to the 1 equals x. Remember, logs equal the exponent. So my base here is 10. My exponent is what I'm equaling, which is 1, which equals x. And then I say, well, what's 10 to the first? Oh, yeah, 10. Oh, got my answer. It's that easy. Now, I actually could have done that right from the beginning and not used the power rule. I could have just said 10 squared equals x squared. Again, base of 10 raised to the exponent equals the x squared. And then I get 100 equals x squared. Take the square root, take the square root. That's how you get rid of a square. Now remember, I mentioned this in several other videos. Anytime you create a square root, you got to put a plus or a minus in front of it. But be careful, because remember I said earlier, you cannot have a negative value inside of a log. So let's think about that for a second. And again, let's just think about that. My log is log of x squared. If I plug in 10, positive 10, 10 squared is 100. All right, you're allowed to have 100 inside of a log, so 10 is an answer. But if I plug in negative 10, once I square, remember that's inside, right? The square is inside of the log. So once I square negative 10, it becomes positive 100. So negative 10 is another answer. So there's actually two answers, positive or negative 10. If I would solve it this method right here, I wouldn't have seen that other answer of negative 10. So although there seems like there's two ways to say this problem, one of them is wrong. This method over here using the the power rule is actually incorrect and should not be used because it won't produce the two true answers. So if you could use the definition, use it right away is the point of that problem. All right, here is a good problem. And I'm like, ugh, 3 logs all together. All right, this is where I'm going to need to use my properties for sure. On the left-hand side here, I'm going to go ahead and combine or condense from 2 natural logs down to a single natural log. Now they're adding. Remember, I could, instead of adding, I could bring them together with multiplication. So that's natural log of 3x minus 2 times x minus 1. And that was using the product property. So again, I want to try to condense that down. Easy, makes sense. And then what I could actually do next is I could go ahead and multiply that inside together. So I get 3x squared. On the outside's negative 3x. Inside's a negative 2x. That's negative 5x. And then plus 2. Negative 2 times negative 1 is positive 2. Okay, things are looking great. Now, at this point, what can I do? Well, I could use the power rule on the right-hand side and bring the square up to here. Bring the 2 up as a square. Now, at this point, I have a really cool rule. It's called the 1-to-1 rule. It says that the log of x equals the log of y implies that x equals y. It was actually in the property video, if you watched it. Meaning that if you have the same log with the same base on each side, the values inside of the logs must also be equivalent. Because the only way that log of x is going to equal log of y is if the x and the y are the same. So this allows me to almost, well, not almost, but in a sense, cancel out or get rid of the natural logs. And I have 3x squared minus 5x plus 2 equals x squared. Because the only way that these two logs are going to be the same is if what's inside them are the same. That's the 1-to-1 rule. So now I just got to solve this. Oh, it's a quadratic. We love quadratics. Subtract the x squared over, because you need it, 0. 2x squared minus 5x plus 2 equals 0. Factor, or at least try to factor. A little bit of trial and error here. Notice I'm showing all my work. Highly recommend you do the same. The only way to split apart a 2x squared is a 2x and an x. Now for the 2, I'm going to put a 2 and a 1 and just see what happens here. So on the outside, I get a 2x. On the inside, I get a 2x. A 2x and a 2x can make a 4x or a 0x. So I'm going to try to flip that around and see if it works. So let's try to put the 2 right here and the 1 right here. So now I have a 4x on the outside. I like that. I got a 1x on the inside. Ooh, if I make them both negative, the negative 4x and the negative 1x will make the negative 5x in the middle, and the negative 1 times negative 2 makes the positive 2 on the final term there. So this does work out right. All right, now I'm just going to say, all right, well, 2x minus 1 could equal 0, so x equals positive 1/2, or x could equal 2. Okay, got my two answers. Now, I need to make sure that neither one of these answers will produce a negative inside of a log. So let's see here. Let's try 2 first. 3 times 2 is 6. 6 minus 2 is 4. Love it. 2 minus 1, that's positive number 1. Plug in 2 here. You're obviously going to get 2. All right, let's try half. 3 times a half. 3 times 1/2 is 1.5. 3 times a half is 1.5. Minus 2. Ooh, that's a negative. Oh, what about here as well? 1/2 minus 1. That's a negative. Okay, that means this is what we call an extraneous solution. It's a solution that we thought was right through the process. But at the end of the day, if you go back to the original problem I gave you, it produces negatives inside of a log, and you cannot have 0 or negative values in a log. So it's undefined. It doesn't exist. So that means the one and only one answer is 2. Awesome. Love it. All right, next problem. All right. Once again, I could just jump and use the definition, right? So let's see here. So this is e to the 12 equals x to the 6th. Okay, that makes sense. Remember the base of a natural log is e, so I'm just following the definition. E to the 12, logs equal the exponent, equals x to the 6th. All right, now you're going to say, well, how do I get rid of a 6th power? Well, I mean, go back to your unit on powers. All you got to do is use a 6th root. So keep in mind, remember this. A square root is essentially equal to x to the 1/2. A cubed root is equal to x to the 1/3. 4th root is equal to x to the 1/4. So a 6th root is the same as using a 1/6 power, which actually makes sense because now if you have a power to a power, you multiply and you just get x. But you got to make sure you do it to both sides. So essentially I'm taking the 6th root of both sides or raising it to the 1/6 power. And that's also going to be nice here because power to a power, 12 times 1/6, 12 to the 1/6, 12 times 1/6 using that rule there, the exponent rule, multiply powers when you are raising a power to a power. 12 times 1/6 is 2, so I get e squared. So there's my answer, e squared. Awesome. Very, very simple. Oh, by the way, remember, e's just a number. So essentially, e squared is some irrational number, and I'd much rather the exact answer of just e squared. All right, here's another one. And what I'm going to do on this one is I'm going to jump and use some properties. All right, so the first property I'm going to use is I'm going to use the power property and bring that back up there. So that's natural log of x plus 3 to the 1/2 minus natural log of x equals 0. Then I'm going to use the quotient property in reverse because I have the subtraction of two logs. I could condense that with division. So that's x plus 3 to the 1/2 all divided by x equals 0. So hopefully you see what I did there. Again, I just used the properties. I had subtraction of two logs that can be joined with division of those values. Now I'm going to go ahead and use the definition. Remember, the base is e. So it's e raised to the 0, logs always equal the exponent, equals. Now real quick, I'm going to change that to the square root of x plus 3 because a 1/2 power is the same as the square root, equals x, or divided by x, excuse me. Now this is awesome because e to the 0 is 1. E to the 0, don't believe me, remember anything to the 0 is 1. So now I could just treat that as 1 over 1 and cross multiply. So I get the square root of x plus 3 equals x. How do you get rid of a square root? Square both sides. So I get x plus 3 equals x squared. Now I got a quadratic. Subtract everything to the right. I get 0 equals x squared minus x minus 3. So now, the hard part, the only part that actually dealt with logs was this first couple steps here of using the log properties. But once I used the log properties and the definition, I really just had a quadratic. Now I'm going to tell you right now, you could try, but I know for a fact that this does not factor. So I'm going to go ahead and use the quadratic formula. X equals the opposite of b, positive 1, plus or minus the square root of b squared, negative 1 squared is 1, minus 4 times a times c, which is negative 3, all divided by twice a, which is 2 times 1. Clean up that inside. 4 times 1 times negative 3 is negative 12. 1 minus negative 12 is actually 1 plus 12, which is 13, all divided by 2. So there is my nice exact answer. You could certainly use a calculator to get the approximate answer if you want, but there's a nice exact answer. There's a little bit of an issue here. Let me show you. If you go to the calculator and actually figure out what the two approximate values are, the first is 1 plus the square root of 13, which is 4.60, divided by 2. Notice I did the divide by 2 after. Always treat that separate. Do the numerator first, then divide by denominator. Anyway, I get 2.30. Again, that's an approximate answer. So 2.30 is an approximate answer. All right, that's a good answer. I can plug 2.30 in, and 2.30 plus 3 is going to be a positive number. Natural log of 2.30, that works. But check this out. If I do the other solution, 1 minus the square root of 13, divided by 2, I'm going to get a negative. Can't do it. If I take negative 1.3 and I plug it into this first natural log, now negative 1.3 plus 3 will be a positive, so that works. But when you plug it in here, where it's just x, that's going to become the natural log of negative 1.3. Sorry, that doesn't work. That's undefined. So you do have to be very careful in a problem like this, that the one and only answer is 1 plus the square root of 13, all divided by 2. Or if you are okay or allowed or asked to give an approximate answer, 2.30. All right, so it's another one of those cases where every time you're done, you might not be done. You got to use a little thinking. All right, we got 2 more problems. Let's try this one on for size. All right, first thing I'm going to do on in the left-hand side here is I'm going to go ahead and say log plus log. I could condense that using the product rule. And I'm going to multiply the x minus 2 times the x plus 5. That could be done on the inside. And on this side, I'm going to go ahead and put the 2 up. So that's log of 3 squared, which we could change to log of 9 in a minute. All right, so let's see here. So on the left-hand side here, we have log of x squared minus 3x, take that back, plus 3x minus 10. Just briefly make sure you understand that. There's the x squared, there's the negative 10, outside's positive 5x, inside's negative 2x, that's where I got the 3x in the middle. And then over here we have log of 9. Now remember the rule we said about earlier. If you have a log on each side, and they're both the same base, log on the left, log on the right, then the values on the inside must be the same. So x squared plus 3x minus 10 has to equal 9, because the only way log of the left is going to equal log of the right is if the values on the inside are the same. So that's how I know that they're equal. Okay, now I got a quadratic to solve. Subtract the 9 over, we got x squared plus 3x minus 19 equals 0. You could try to factor it if you want, or you might, some kids see a 19 and just panic. I mean, it might work, I don't know, but you know, some kids are just jump and so they want to use the quadratic formula, which is fine. So I got the opposite of b, which is negative 3, plus or minus the square root of b squared, 9, minus 4 times a times c, all divided by twice a, which is 2. So I got x equals negative 3 plus or minus the square root of. Now listen, some of you, or maybe even like me, are a little bit nervous. Don't be afraid to use a calculator. 4 times 1 times negative 19 is negative 76. 9 minus negative 76 actually turns into a positive. So that's 9 plus 76, which is 85, again, divided by 2. Okay, now the question, the same thing we had up on the last problem is, you know, there's two answers here. There's the plus, there's the minus. And you got to see is if any of them don't work, you might be in problems. You know what I mean? So you got to just play it out, see what happens. All right, so let's do the calculator. Negative 3 plus the square root of 85. Remember, do the numerator first. Divide by 2. So that gives me 3.11. And I'm like, okay, I like 3.11. I like that. If I plug that in to either one of the logs in the very beginning, I do not get a negative or 0. So 3.11 works. I could plug that in here. I could plug that in here. It's going to work. And let me check the other answer, which I'm going to be honest, usually does not work. But let's, you never know. Not always. I guess I shouldn't say that. So negative 3 minus the square root of 85. And then divide by 2. And I get a negative 6. Yeah. If I plug negative 6.11 in, I'm actually going to get a negative in both of these logs. So that is not the answer. So the only exact answer is negative 3 plus the square root of 85, all divided by 2. If you want the approximate answer, or if you're allowed the approximate answer, 3.11. All right, let's do one more here. This is definitely kind of a weird looking problem. We'll do our best here, but notice that on the left-hand side I have a log, on the right-hand side I have a number. Why don't we just jump and use the definition? So I'm going to take the base, which is a really weird base, x plus 3, raised to the second power. Remember, logs always equal the exponent, so that's the power, equals the inside 2x squared minus 2x. So literally, just utilizing the definition turned this log, ugly-looking equation into nothing but an exponential. So on the left-hand side, I got x squared plus 6x plus 9. If you're like, where did that 6x come from? Oh boy, you got bigger fish to fry than worrying about log equations, to be quite honest. But make sure you just take x plus 3 times x plus 3 and actually square it out, and then you'll see where the 6 comes from. All right, bring everything over to the, let's see, I always want that a term to be positive. So I'm actually going to move everything to the right. So I'm going to subtract x squared. So 2x squared minus 1x squared is a 1x squared. I'm going to subtract the 6x over, which is going to make negative 8x. And I'm going to subtract the 9 over. All right, I'm going to go ahead and attempt to factor this quadratic. It looks easy, but looks can be deceiving. 9 and 1. Let's see here. If I make the 9 negative and the 1 positive, that'll get a negative 8. So let's just double check. X times x is x squared. Yes. Negative 9 times 1 is negative 9. Hoo-ha. And finally, negative 9x on the inside, 1x on the outside does make a negative 8x in the middle. So my answers are 9 and negative 1. But, make sure they work. Let's see here. Bases have to be positive. So 9 plus 3 is a positive. Negative 1 plus 3 is a positive. So they work there. Inside, I got to have a non-zero, non-negative number. So let's see here. 9 squared is 81. 2 times 81 is 162 minus 18. Yep, that's going to be positive. Negative 1 squared is 1, so 2 times 1 is 2. Negative 1 times negative 2 is positive 2, so that's going to put a 4 in there. Yep, good to go. Neither one of these answers will generate a negative inside log. So there we go. Pretty nice and simple, not too difficult. I know I ran through a lot of problems there, but go back and watch what you need to. You know, at the end of the day, as long as you know the log properties, you could really just turn it into a, I don't want to say a simple equation, but a quadratic or even something linear, something that you are capable of solving. You just got to make sure that you really, truly utilize the log properties, because if you mess those up, you're never going to get the right answer. All right, good luck. Do your homework. Let me know if you have questions.